In this video, I want to explain the homework for dynamics. And so there's a couple pages here. The first page is taken from a textbook, and it gives the data on the 4-bar. Okay, so these are just information about your 4-bar link. And so the first row you have link lengths. In the second row you have locations of center of mass. In the third row you have the masses. The fourth row, this phi value, is also helps locate the center of mass, and then Ig is the mass moment of inertia. This omega 2, it's how fast link 2 is moving. In later formulas, the book refers to it, that I took this from, just refers to that as omega. Alpha 2 is 0 in this. Okay, and so the problem you're going to find is to find all these joint reactions and the moment when theta 2 equals 30 degrees. Okay, now all the formulas are given here. This is the free body diagram that these equations that are given to you in this worksheet come from. All the equations will be given to you. So you can just, this helps because it's a little bit different nomenclature than in the PowerPoint, but it's the same idea. You have position vectors and then the acceleration vectors, what they look like for link 2. So you've got the x and y components of the acceleration vector for link 2, and then for link 3, and then for link 4. So you have all these formulas for the acceleration of the center of mass. Then he gives a few of the, some of the forces in the x, some of the forces in the y, and then some of the moments for link 2. And then he pulls, he doesn't write down these equations that they exist for the other links. He just writes them down in matrix format. So this is the A matrix that you're going to solve, and it has mostly ones and zeros, but then there's a few of these, A33, A34, A66, and so on, that the formulas for are just given right here. There is one typo, there's a parentheses out of place, but other than that, this is pretty good. Then the x vectors, your unknowns that you're going to find, are listed here. And each one of these, this first element corresponds to this first column in the A matrix, and the second to the second column, and so on. And so this last column right here corresponds to M13. And so how you would read this is I've got minus F12x plus 0 times F12y plus F23x, and then a bunch of zeros, and that's going to be equal to M2Ag2x. Okay, and so each row in this A matrix is an equation. Each column is associated with an unknown, and then they're just going to be equal to the known values that are in this B matrix. Now, the quantities that are in this B matrix, you have to calculate basically from the accelerations. Accelerations, you've got formulas for them that are given above, but you still have to know the alphas and omegas, and that you can get from your 4-bar spreadsheet. So it's a little bit of work putting it all together, but all the equations are here. You can use the technique I showed for linear algebra in the other video that I posted to YouTube that will allow you to invert this matrix and find its solution. So it's in some ways just plug and chug, but there's a lot of things to put together. And calculating these accelerations is a little bit of work, but it's less work if you've kept up with the 4-bar spreadsheet to calculate positions, velocity, and accelerations. All right, so I hope that's helpful in doing the homework.